Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everyone, and welcome to Wednesday Night Math Night. Like Dr. A said, I am Amy Singh, and I am one of the math specialists here at the Learning Liaisons. And I just love what we get to do, which is be here on Wednesday nights and go through math problems and help you feel more competent and confident in your math skills. We were not here for a couple weeks. I was battling a bad bout of tonsillitis, multiple rounds of antibiotics, multiple rounds of steroids, but I think we are finally on the up and up. It still kind of hurts when I talk. I can't talk for super long, but we are here and we are going to do math problems together. I'm also having technical difficulties tonight, and the screen for some reason is not sharing at all. I don't know what's going on. I keep getting an error message that's like, you cannot share your screen. So I really don't know why that's happening. So I'm troubleshooting as we are talking right now so that we can hopefully get this thing to work. And if it doesn't, I'll do math upside down from my iPad, just so that we can get some problems in tonight. So in the comment box, I always like to do a little get to know you. So in the comment box, let me know where you're from, what test are you prepping for, and it is officially October. What are your thoughts about that? I cannot believe we are in October. I feel like just yesterday was like Valentine's Day. I don't know. It's kind of crazy. So it is October. Do you like October? Do you like the pumpkins? Tell me all the things. I love the fall. I love the idea of fall. In Florida, we don't really get fall. But I love the idea of fall. I love feeling the crisper, cooler weather. I love it all. It's the best. So where are you from? What test are you prepping for? And it's October. What are your thoughts about that? Do you love fall? Do you hate fall? Do you love winter and the holidays? Do you hate it all? What are your thoughts? We are going to go over some problems tonight. And they are going to be pre-K through 12th grade. And so we are going to go over a variety of problems. I always try to make sure that every problem is able to at least work for everybody in some capacity or another. Obviously, the problems that are on the pre-K test are not going to be the same problems on the 12th grade test, but I try to make at least one point that's relevant within each problem for everybody. And so that makes it all kind of work together. So without further ado, let's go ahead and do our first problem. I literally can see my iPad on my computer screen, but it is not sharing. Hello, Rosa from Miami. You're taking pre-K through 3. Fantastic. I love the pre-K through 3 exam. I've never taken it, but I'm just tutoring through it and working through it. I just love it. And you like the fall weather. Me too. I love the sweaters, the boots. Give it all. I love it all. All right. I guess I'm going to do this upside down. So I'm going to read the problem like this, and this is how we're going to do Math Wednesday. Not ideal, but when tech just does what it wants to do, this is how we do it. So let's go ahead and read through the first problem. The position of a particle can be defined as x of t equals 0.34 t cubed plus 2t. Find the average velocity of the particle between 2 and 5 seconds. Find the average velocity of the particle between 2 and 5 seconds. So when we're talking about the difference between, hi Sabrina, between average velocity and instantaneous velocity, and this problem, I don't want to scare away my EC6 and pre-K 3 people, so don't run away. I promise I have problems for you too. But when we are talking about instantaneous velocity and average velocity, instantaneous velocity means we're going to have to find the derivative of the position function. Average velocity means we are literally taking the slope between those two lines. So I'm going to find the distance or the change in the distance of my particle and divide it by the change in the time. It's literally the slope formula, y minus y over x minus x. It's just not with a line. And so I am going to plug in, because this is average velocity. Like I said, EC6 and pre-K through 3 people, I promise we will get to a problem pretty quickly here that is for you. So don't leave yet. And honestly, I said at the beginning of this that like every problem I try to do something for everybody, but this one's pretty hard to do for everybody. So just stick with me. So this is my position function. And so I'm trying to find the average velocity between 2 and 5. So like I said, we are doing the change in distance or position divided by the change in time. And that little triangle means change in, right? And so my change in distance. So I'm going to plug in 2 into my function, and then I'm going to plug in 5 into my function, and I'm going to solve for that. My change in time is literally just 5 minus 2. My change in time is literally just 5 minus 2. So 5 minus 2 is 3. At least I know I'm dividing by 3. And now I can find my change in my distance. So I'm going to plug 2 in into my t function. I'm going to plug 5 in into my function, and I'm going to solve. So I'm going to talk through what that's going to look like. So x of 5 equals 0.34. Plug in t for all, or plug in 5 for all of the t's. So here you see that I plugged in 5 for all of the places where we had a t. Now I'm going to solve that. I'm going to use my calculator. I'm going to do 5 cubed. So I just simplified my exponent here, and I have 5 times 5 times 5 is 125 times 0.35 plus 10. Now I'm just going to simplify that times 0.35 is 43.75 plus 10 equals 53.75. So that goes with my 5. Now I'm going to plug in 2, and I'm going to do the same thing. Man, this really is unfortunate that you guys can't see my screen, but we're going to make it work. 2 cubed plus 2 times 2. So you notice that I figured out my y value for when x is 5. Now I'm figuring out my y value for when x is 2. So I'm going to do 2 times 2 times 2, because that's 2 cubed, and that equals 8. I'm going to multiply that by my decimal because it's sitting right next to it. So I have 0.35 times 8 plus 4. And that equals 2.8 plus 4, which equals 6.8. And I've plugged that in. Now I'm going to go ahead and literally just solve that arithmetic up here. So I'm going to do 53.75 minus 6.8, and that gives me 46.95. And when I divide that by 3, I get 15.65. Which is not an answer choice. So I did something wrong because I literally just solved this. 46.95 divided by 3 equals 15.65. So what did I do wrong? Oh my goodness. This is hard. What grade is this? You are right. This is hard. This is high school. My EC6, my pre-K through 3. Don't leave yet. I promise. I have a problem for you. Remember, tonight, this is why I can't get excited. I promise you I have a problem for you. Tonight is pre-K through 12. And so this is not EC6 or pre-K through 3. So don't worry that you don't know how to do this. I just realized I did this entire problem with 0.35, and it's supposed to be with 0.34. And that right there changed my problem drastically. So if I did it with 0.34, 52.5, 52.5, 52.5, 52.5, 52.5, 52.5 minus 11.66 divided by 3. Yeah, the answer is 12.26. Okay. Questions about that? All right, let's go ahead and move on to the next problem. Listen, y'all, everybody makes mistakes, right? Everybody makes mistakes. All right, the next problem is also it's more of a GK through 12th grade. It's more of a middle school and high school. So we're kind of working our way down. So we just did like high school calculus all day. Now we're working backwards, and we've got a little bit of middle school, high school. Then we're going to work backward, and we'll get to a pre-K through 3 elementary problem. All right. Hey, Marco, it's good to see you again. All right. Here is the next problem. Two functions, f and g, are graphed on a coordinate plane. What can we assume about these two functions? They intersect at certain points, x and y, which means that f of x equals g of x at that point. They both have a domain that is negative infinity to positive infinity. The functions have different slopes or rates of change, or they have one x value for every y value. So when we have a problem like this, I always like to try to negate answer choices. Like I try to prove why that can't be an answer choice, because this is a lot of words for a math problem, right? And so we've got these two functions, f and g, and they are graphed on a coordinate plane, right? What can we assume about these two functions? They intersect at certain points. Can I have two functions on the same coordinate plane that don't intersect? Yes, those are called parallel lines. So I can literally prove that to not be true, because I can draw, and I'll show you this picture in a minute, two separate functions that are parallel, and this says there are two functions graphed on a coordinate plane. What can we automatically assume? Well, I cannot assume that they intersect, because this right here is two functions graphed on a coordinate plane and they do not intersect. So I cannot assume that they intersect. They both have a domain of negative infinity to positive infinity. Can I create a non-example of this? Well, one of them can be a line and it has a negative infinity to positive infinity. However, that right there does not have negative infinity to positive infinity domain. That domain right there is more like 2 to infinity. And so I just disproved that one because it said they both have a domain of negative infinity to positive infinity. Letter C. The functions have different slopes or rates of change. Do parallel lines have different slopes? No. Parallel lines have the same slope. So I disproved A and C in the same example. They each have one x value for every y value. That right there is the definition of a function. That right there is literally the definition of the word function. Exactly one x value for every y value. Because that is the definition of a function, I absolutely can assume that because they told us that we have two functions. Questions about that one? All right, let's move on to the next problem. All right, I'm going to find one for my pre-K through 3 EC6 people. This is a good one. Okay. A teacher recorded the number of books read by her 6th grade students. We could also change that to 2nd grade or 3rd grade or whatever. So it doesn't matter that it says 6th grade. In 1 month. The data is shown below. According to the graph, what percentage of students read at least 9 books? What percentage of students read at least 9 books? Now, if you're in pre-K through 3, you will not have to figure out percentages most likely. If you're in EC6, you will have to figure out percentages. But everybody pre-K through 12 needs to understand how to read this graph. And everybody could at least answer the question, how many students read at least 9 books? So when we look at this and we look at our axes, I have number of students here, and I have books read down here. The number of students who read between 0 and 2 books. So these are the kids who read 0 books, 1 book, or 2 books. The number of students who read between 0 and 2 books is 6. The number of students who read 3, 4, or 5. Now, we don't know how many students read exactly 3 books. We don't know how many students read exactly 4 books. The only information we are given is how many students read between 3 and 5 books. So we have to be careful about what information we can assume. I could totally see a test writer throwing this graph up onto a screen and saying, what information can I assume from this graph? And that is not one of them. So I have 10 students who read between 3 and 5 books. I have 8 students who read between 6 and 8 books. I have 4 students who read between 9 and 11 books. And I have 2 students who read 12 or more books. Now, it's interesting that all of these graphs hit at an even number, but that's not always the case. You could have had, like, let's say there was a category for 20 books, so 12, and then we had another category over here. You absolutely could have had something like this. You absolutely could have had something like this, and this falls between the 2 line and the 4 line, which means this would be a 3. Now, that's not part of our data, so we're not going to use it, but I wanted you to see it. Now, the question asked, what percentage of students read at least 9 books? That's the key. That means they could have read 9, 10, 11, or 12 or more. So at least 9 are all of these students, which would be 6. So for my pre-K through 3 people, the answer, they wouldn't ask us a percentage. They would have asked us a number. So 6 kids had at least 9 books. Now, for my people who are doing a percentage is just a part of a whole. It's just a part of a whole. Keep in mind, fractions, decimals, percentages, ratios, they're all in the same family. They all represent a part of a whole. And so a percentage is just that. So I'm going to take my part, which was 6 students, right? I'm going to take my part and I'm going to put it over how many total students were a part of this. How many, this is another question pre-K through 3 people, it might ask, how many total students participated in this survey? How many total students participated in this survey? I would just add all of the numbers up. 6 plus 10 plus 8 plus 4 plus 2. Not the 3 because that was a made-up data point. So I'm going to use my handy-dandy calculator. 6 plus 10 plus 8 plus 4 plus 2. So there are 30 total students. So that is the fraction representation. What is the percent representation? Well, if I have a 4-function calculator, I can do 6 divided by 30, and that gives me 0.2. How do I convert a decimal to a percent? Hop that decimal 2 places to the right. So that equals 20%, which is C. Questions? Now, if you didn't have a 4-function calculator, you could still do that division by hand. So you could set that equation up to be 6 divided by 30, like this. Don't make the mistake of doing 30 divided by 6 because that's not going to give you a percentage. You want to do 6 divided by 30 and then you can add a decimal zero. 30 goes into 62 times and you still get the same answer. Questions? All right, I forgot to say at the beginning that I always do a next week section. So if there are concepts or topics or even specific questions that you're struggling with through this process, please let me know and I'll add them to my next week section. And I will include them in upcoming weeks because remember, these sessions are for you. They're not for me. I love doing it, but these sessions are for you. So if you have questions or topics or anything that you want me to go over, just drop me a comment and I'll be happy to include those in the upcoming weeks. All right, let's do this one. Now, this one may not conceptually be a problem that everybody has to be able to do, but what it does have is a problem-solving method that we can all agree upon. So let's read this problem and then let's solve it together. A painter is working on painting a house. He has painted 42% of the house so far, and it has taken him 11 hours to do so. About how much longer will the painter need to complete the job? About how much longer will the painter need to complete the job? All right, so for this one's an interesting one. So a painter is working on a house and he has already painted 42% of the house, right? And that 42% has taken him 11 hours to do so. So at this rate, how much longer will it take to complete the job? So here's how I like to think about a problem like this. I have 11 hours, right? And in that 11 hours, I have completed 42% of the job. How much percent of the job am I completing per hour? Hour 1, hour 2, hour 3, hour 4, hour 5, hour 6, hour 7, hour 8, hour 9, hour 10, hour 11. How much of that job is being completed per hour? What can I do? If I do 42 divided by 11, that's going to give me the amount of the job that is being completed per hour. So I have 42 divided by 11 equals 3.8. So 3.8% of the job is being completed every hour until I get to 11 hours. That equals 42% of the job. Now, if I'm completing 3.8% per hour, how much percent is left? If I've completed 42% and my total is 100%, how much of the job is left? 58. 58% left. So if I'm completing 3.8% per hour, I'm doing 3.8, 3.8, 3.8. How do I figure out how long it's going to take me to do 58% more? I can do 58% divided by my 3.8% that I'm doing per hour, and that will tell me how many hours I have left. So 58 divided by 3.8 equals 15.2 what? Hours. So it's going to take approximately 15 hours. Questions about that? That was an interesting problem because we thought of a job and percentages and hours as if they were items to be divided by. And you can absolutely do that. You don't have to have apples to be able to multiply or divide, or chairs or something like that. You can divide time and jobs as well. All right, let's go ahead and move on to the next problem. We are only going to do one more problem tonight. My throat is starting to really kill me from this tonsillitis, but I did want to get together and work together, and so we will do one more problem, and then I've got some really good problems for next week. So that's going to be fun. How would you do those calculations without a calculator? Sabrina, that is a great question. So the 42 divided by 11, I will do all of these calculations right now without a calculator. Okay. So the 42 divided by 11 to get the 3.8. I can absolutely set that up here as 42 divided by 11. How many times does 11 go into 42? Well, 11 times 1 is 11. 11 times 2 is 22. 11 times 3 is 33. And 11 times 4 is 44. So it can't go in 4 times, so it can do 3 times. 2 minus 3 can't do it. 12 minus 3 is 9. Now, that's a remainder, but I'm going to add a decimal 0 to get a more accurate answer. If I add a decimal 0, I also have to add a decimal up here. How many times can 11 go into 90? Well, my 11 facts are easy because it's 22, 33, 44, 55, 66, 77, 88, 99. So I know it can go in 8 times, and that's going to give me 88. Now, I can very quickly see that this is not going to end pretty or clean because 11 times anything is never going to end in a 0. And so I'm going to live with 3.8 there as my answer because, again, it asked me about, and so I can truncate it at 3.8. Now, 100 minus 42, I can line that up vertically and solve like this. Can't do 0 minus 2. Can't do 0 minus 4. So I'm going to take this 100 and break it down. 10 minus 2 is 8. 9 minus 4 is 5. So there's the 58. And then over here, we have 58 divided by 3.8. So give me 1 second. So what you can do here is because I have a decimal in my divisor, if I move that decimal 1 place to the left, then I can get whole numbers, but then I can also move this 1 place to the left. So if I do it in my divisor, I have to do it in my my other number as well. So now I actually have 38 divided by 580, but at least I have a problem that doesn't have a decimal in it when I'm doing long division. So 38 goes into 58 1 time. 38 can't go into 5, so I'm not going to put the 1 there. I'm going to put the 1 over here. That equals 20. Pull down the 0. 38 can go into 200. Well, 38 is kind of close to 40, and I'm going to think this aloud. So I can do 40. 40 times 2 is 80. 40 times 3 is 120. 40 times 4 is 160. 40 times 5 is 200, but because 38 is a little less than 40, my 5 is going to be perfect. So 38 times 5. 5 times 8 is 40. 5 times 3 is 15. Add the 4, 16, 17, 18, 19. Add a decimal, 0, bring it down. 38 goes into 100 2 times. 2 times 38 is 76. And I'm just going to keep it at 15.2. Hopefully that helped Sabrina with understanding how to solve that without a calculator. Questions? Thank you so much. I appreciate it. Man, the amount of antibiotics and steroids my poor body has been on, it has been rough. But, you know, we make it work, right? All right, one more problem like I promised, and then I'm going to let you go. Okay, a group of students took a test, and their scores were as follows. 14, 18, 12, 16, 14, 20, 10, 14, 16, 18. If one more student scores a 12, which of the following statements is true? The mean decreases, the median stays the same, the mode stays the same, and the range stays the same. The mean increases, the median increases, the mode changes, and the range increases. The mean decreases, the median decreases, the mode changes, and the range stays the same. The mean stays the same, the median stays the same, the mode changes, and the range increases. So this is an interesting problem, and it's kind of a fun one. So they've asked us for the mean. They want to know what is going to change or what is going to stay the same if I add a 12 into here. So what I would need to do is I would need to figure out the original values and then figure out the values with the 12 added in. But do I need to do the mean, the median, the mode, and the range before I start looking at all of this? No, I'm going to do the easiest one first. I like the mode because remember, the mode is the number that appears the most number of times. So I'm going to look for the mode. In this one, I see that 14 appears 1, 2, 3 times. 12 appears once. 18 appears twice. 16 appears twice. And 10 and 20 each appear once as well. So the mode, I'm going to flip this around for a minute. The mode, which is the thing that appears the most, is 14. When I add a 12 into the mix, another 12, does the mode change or does the mode stay the same? The mode stays the same because I still only have 2 12s, but I have 3 14s. So now I'm going to look at my answer choices. The mode stays the same. The mode changes. Nope, the mode is not changing. The mode changes. Nope, the mode is not changing. The mode changes. The mode is not changing. All I found was the mode, and I have my answer. Now, if I didn't have my answer already, then I would do the median next. And the range. I would leave mean for last because the mean is very mean and it makes us do a lot of work. And so I would then do the median. So I'm going to put these in order. 10, 12, 3 14s, 2 16s, 2 18s, and a 20. The median says I am going to cross off things on each side to find the middle. So 1, 1, 2, 2, 3, 3, 4, 4. The median would be what's in the middle of that, which is 15. Now, when I